Alright, so now we're going to start factoring polynomials. Last lesson we added, subtracted, multiplied, so now we're going to go in the reverse direction, right? Some of these factoring techniques you've seen before in Algebra 1, and then maybe towards the end we'll do something that you maybe haven't done, but regardless, we're going to do 4 different types of factoring techniques in this lesson. Alright, so the most basic one that you maybe remember from Algebra 1 is taking out a greatest common factor, right? Now, a greatest common factor is whatever factor the terms of your polynomials have in common. So if you look at something like this, 6x to the third and 4x, you're trying to think about what factors they share in common, and you're going to take out the greatest one. So between 6 and 4, it looks like they share a factor of 2. And between x to the third and x, they share one x in common. Now, whatever you get left over is going to be whatever you get when you divide each of these by that common factor, right? So think you're taking out that factor, and then what's in parentheses is left over. So it's going to be a 3x squared minus 2, right? That's what happens when you divide out that common factor, right? So that's what you get, all right? So for these first 2 pretty basic examples, I'm just going to look at all of my terms, and I'm going to take out the greatest common factor. Typically, when our first term is negative, I like to pull that out first with it. So I'm going to take out a negative, and then between 4x squared, 12x, and 16, I can take out a 4. And then whatever you get left over is going to be whatever happens when you divide a negative 4. Right, divide each of your terms by negative 4. So I get an x squared minus 3x plus 4, right? And then so that becomes our final answer. All right, do the exact same thing with the next one, right? Between 3x to the third minus 6x squared and 9x, I can take out a 3 from those coefficients, and it looks like between my x's, I can take out 1x. All right, and then whatever's left over in parentheses, divide out that common factor. All right, so you're going to be left with x squared minus 2x plus 3. All right, and so that is your factored expression. All right, sometimes it might not look as easy. So something like 3 and 4, right? For things like these, some people might want to try to simplify first. So maybe distribute that 2x, distribute that 3. And then try to factor it that way. But look at the way it's written, right? And remember what a factor is. A factor is just something that's being multiplied with something else, right? If you don't see an operation in between, that is a multiplication. So that means this this x minus 2 is a factor, and this 2x is a factor. And then same exact thing here. This x minus 2 is a factor, and this 3 is a factor. They're being multiplied with each other. So now if you're looking at these 2 terms, right, so this one and this one, the factor that they share in common is this x minus 2. So then what happens when I take that out? If I take that out as my greatest common factor, what's left over, right? It looks like it's going to be this 2x and this 3. There was a plus in between, so I'm going to keep that plus as well. Right, so this x minus 2 is our greatest common factor, and then the 2x plus 3 is left over. All right, try the same thing with number 4, right? Think about it before trying it. If it's confusing, I'm going to write something that looks similar to it. So let's say I had a y squared minus 4y. Right, most people would agree that you can take out a y, and then you're left with a y minus 4. And then this is your factored expression. It's the same exact thing here, right? So if I have an x plus 3 squared minus 4 times x plus 3, right? This x plus 3 squared is the same as x plus 3 times x plus 3. It is a factor. Same thing here, minus 4 times x plus 3. This x plus 3 is also a factor. So that means I can take out an x plus 3 as a greatest common factor. Now what's left over is going to be, well, I just took out one of my x plus 3's here out of the 2. So then I'm left with one of my x plus 3's. So it's going to be an x plus 3. And then I took out the x plus 3 from here, and I was left with this minus 4. Right, so that's what you're left with. And then lastly, what you would do is you would combine like terms. So it's going to be an x plus 3 times, right, 3 minus 4 is going to get me a negative 1. So x minus 1. Right, kind of a tough one for a lot of people to grasp. But again, if you can think of it in this way, going from this to this, it's the same thing here, you just don't have a single variable or a single number as your common factor, right? It's an entire expression, that's a factor. All right, so same exact idea, but that's as hard as these GCFs get. All right, now a difference of two squares, we talked about something similar previously, right, in the previous lesson, right? The product of a sum and a difference got you a difference of two squares. So now we're going in the opposite direction. When I have two squares with a minus in between them, then you very simply just square root the first, square root the second. One has a plus, one has a minus. So x squared minus 4. When I square root these, I get an x and a 2. So then one gets a plus, one gets a minus. You get two sets of parentheses, right? And it looks something like that. All right, so let's try some of these. I have a 9x squared minus 49. Square root the first, square root the second. This is going to get me a 3x and a 7. There is a minus in between, so this is a difference of squares. One has a plus. Write them again, but this time with a minus. And then that's your final answer. All right. Same thing with the next one, square root the first, square root the second. They have a minus in between, so it's just going to be 6x plus 7y, 6x minus 7y. And then that's your answer. All right. Same exact thing with the next one. Although with this one, you could take out a GCF from the beginning, right? So here you could take out a 4, right? If I divide everything by 4, you end up with x squared minus, I don't know what happened, minus 25, right? It was a difference of squares in the beginning, right? But this one you could have taken out the GCF first, right? To factor it completely. And you're going to see down the line, it's better to take out the GCF from the very beginning, even if you could have just square rooted the first and square rooted the second, because on your test, when we say factor completely, you're going to need to eventually take out that GCF, right? So let's take out that 4, and then I still have a difference of squares on the inside, right? I can square root the first, square root the second. There's a minus in between, so it's going to be x plus 5, x minus 5, with that 4 out front. So I can take out a GCF. I think in class I forgot about that. Either that or I skipped this example altogether, right? But I don't remember doing this in class. This is the correct way to do it, right? For it to be fully factored. All right, when you look at number 8, you might want to try square rooting the first, square rooting the second, but you can't because there's a plus in between. This is not a difference of squares. I would just leave it alone like this. All right. Now, if you tried, let's say I did 5x plus 6 and 5x minus 6, when you go to FOIL it, you're going to end up with 25x squared minus 36, which is not what we originally started with, right? So you cannot do this. Just leave it alone. There's nothing you can do to it. More difference of squares. Let's look at this one. X to the 8th minus 1. Again, this isn't such a straightforward example, right? But think of it this way. You still can square root the first and square root the second. The square root of 1 is just 1, all right? But the square root of x to the 8th, think about what squared is going to get me x to the 8th, all right? And that's going to be an x to the 4th, right? Because if I did x to the 4th times 2, that's going to get me my x to the 8th, all right? And you can apply that same logic anytime you have an even exponent. Anything with an even exponent is a perfect square, all right? So x to the 8th, very simply, you just divide that exponent by 2, and you get the square root of it, right? So this is going to get me an x to the 4th plus 1, and an x to the fourth minus 1, right? But this is where the examples get a little bit more complex, right? Think about what's on the inside of these parentheses and see if there's anything more you can do to it, right? So x to the fourth plus 1, right? Nothing more we can do to that. But x to the fourth minus 1, this is another difference of perfect squares, right? X to the fourth is a perfect square, and 1 is a perfect square. So your answer is not finished. Even though you did it once, you might need to do it more times. So I'm going to get an x to the fourth plus 1, and then right here, this x to the fourth minus 1. Again, I have an even exponent. I can just divide it by 2 to get my square root. This is going to be an x squared plus 1 and an x squared minus 1. All right, now once again, look at your parentheses, see if there's anything more you can do to the insides. All right, anything with a plus, there's nothing I can do to those. All right, so it's going to be an x to the fourth plus 1, x squared plus 1. But this x squared minus 1, this is another difference of squares. So I get an x plus 1 and an x minus 1. And now when you look inside each of your parentheses, there is nothing more you can do to that. This is your final answer. All right, so it might seem a little confusing at first. You might think, well, if you did it once, why do we need to do it more times? Well, the goal here is to fully factor everything. If you see the special case, you should apply it. All right, and then it's around here, right? So going from this step to this step where people try to do crazy things, right? I see people try to take out an x to the fourth or try to take out a common factor of something else. If there was a common factor, you would have seen it from the beginning, right? And you would have taken it out first. There wasn't a common factor in this case, so you're only going to factor the special cases that you see within each parentheses, right? So this one didn't factor, but this one did, right? So you don't do anything to this, but you're going to do something to whatever can be factored, this case. Same thing going from this step to this step, right? So from going from here to here, right? This one was able to be factored, but these two were not. So I didn't touch those at all, but I did change this one to be a difference of squares. All right, so just something to keep in mind. You might need to do it multiple times to get your final answer. Take that logic, apply it to number 10, right? Number 10, 625, x to the fourth is a perfect square. So I'm gonna square root the first, square root 1, right? Square root of 1 is just 1, and there is a minus in between. So this is gonna get me 25x squared plus 1, 25x squared minus 1. Now, once again, look inside of each of these parentheses, 25x squared plus 1. Can I do anything to that? All right, you can't, so you leave it alone. 25x squared minus 1. Can we do anything to that? That one, yes, we can. This is another difference of perfect squares. So I'm not going to touch the first one. The 25x squared I can leave alone, plus 1. But then this next one, this 25x squared minus 1, if I square root the first, square root the second, you end up with a 5x plus 1 and a 5x minus 1. And now there's nothing more you can do to that. That's your final answer. All right, now look at number 11. All right, so this is why I stress, if there's a common factor, it's not going to just magically appear in the middle of your factoring. All right, something like number 11, you have a common factor between 3 and 12. You can take that out right away. If I take out the 3, I'm left with a 1 minus 4x squared, right? Divide everything by 3. All right, and now that on the inside of your parentheses, this becomes a difference of squares. All right, so I can square root the first, square root the second. I get a 1 plus 2x and a 1 minus 2x. And then don't forget about that 3 on the outside. All right, same exact thing with the next one, right? It might not be just a single variable or number, but if I have an expression that's squared, it's still a perfect square, right? So I can square root the first and square root the second. There's a minus in between. So this is very simply going to be x plus 2 plus y times x plus 2 minus y. Nothing more we can do to that. We leave it alone. There's no more special cases on the inside. All right, doing some more examples. Another difference of squares. I see it here with this x minus 1 squared minus 9y to the fourth. These are both perfect squares. That first one, when you square root it, is going to get you an x minus 1. So this is going to get me, there's a minus in between, so I'm allowed to do this. This is going to get me an x minus 1 plus 3y squared. And then it's going to get me an x minus 1 minus 3y squared. All right, nothing more you can do to that. I don't see any more special cases on the inside, no like terms to combine. That's your final answer. All right, now number 14. Again, this is a difference of perfect squares, right? 81 and 36x squared. But check and see if you can take out a common factor first, right? And that should always be the case, right? And you're gonna see later down the line when we factor completely that the steps in which you should factor, the first thing you should do is always find a GCF, right? So is there a GCF? And the second thing you should do is find special cases, right? We're only going to do these today, but there's going to be a step 3 and a 4, right? Later on after your test, all right? But the first thing you should do GCF and then find special cases. So between 81 and 36, I can take out a 9, right? If you didn't recognize that, you would have gotten factors, but you wouldn't have gotten the complete factors. Again, I don't remember if I did this in class. If I did, I forgot about this, right? And I'll mention it in class, right? But when you take out a 9, you're left with a 9 minus 4x squared, all right? So then we can square root the first, square root the second. So it's going to get me a 9 and a 3 plus 2x and a 3 minus 2x. Nothing more you can do to that. Don't forget the 9 on the outside, and that's your final answer. All right, now with this one, again, square root the first, square root the second. So it's going to get me an x squared plus 4y and an x squared minus 4y. Now, a lot of people from here, because they saw the pattern before and they said that they could keep going with this, you actually can't because of this y in front, right? 4 is a perfect square, x squared is a perfect square, but y by itself is not a perfect square, right? You're going to end up with like the square root of y, and I don't want that in my final answer. I want all like whole rational numbers, all right, if possible, all right? So there's nothing more you can do to this. This is just a very simple difference of two squares. Now, another factoring method, the perfect square trinomials, right? This is the third one out of the 4 that we're going to be doing this lesson. Maybe from Algebra 1 and even geometry, you maybe remember other ways to factor trinomials, right? What multiplies to the last, adds to the middle, something like that. But for the sake of this lesson, we're only going to factor perfect square trinomials, all right? It's actually super simple, right? There's a lot of words here, but the test for it is you're going to square root the first and square root the last, double their product, and if it's the middle term, then you're going to have the square root of the first, square root of the last, take the sign from the middle, and then you're going to square it, right? Again, a lot of words, but let's just actually try it, right? So this is an example of a trinomial. The first term is a perfect square. My last term is also a perfect square. So I'm going to square root the first, square root the last, multiply them. When I do x times 5, that's going to get me 5x. And when I double it, do you get the term in the middle? And you do. It's a 10x. It's a minus 10x, but the sign doesn't matter. I just want to see if this part matches. And it does. And if it does, I'm going to take that sign, put it in between them, and then square it. And then this is your final answer. Right? Maybe you see the pattern. Maybe you need to do it a couple more times, but let's do some more. And then let's see if it'll really stick. All right, let's try the same pattern, right? The more you do these, you're going to see that it gets pretty easy. All right, so I'm going to square root the first, 16x squared. And the square root of that is going to be 4x. Square root the last, it's going to get you a 3. Right? If I do 4 times 3, that's going to get me a 12x. If I double it, do I get the term in the middle? Right? I do. I get 24x. So then when it matches, I'm going to take that plus in between, write it in between the two, and square it. And then this is your final answer. All right? Hopefully getting a little better. Let's try the same thing with the next one. square root the first, 3x, square root the last, 5, multiply them. When you double it, do you get the term in the middle? I do. I get a 30x. There's a minus in between. I'm going to write a minus and square it. All right, try the same thing with the last one. All right, square root the first, 2x, square root the last, 1. When I multiply them and I double it, do I get 4x? I do, right? That 4x matches this 4x. I can take that plus, write it in between, and then square it. Right, it's the same pattern every time. Let's try it with this one. Right, square root the first, 6y, square root the last, 7. When I multiply them, I get 42y. When I double it, I get 84y. That matches what I have in the middle, so I'm going to take the sign in between, write a plus in between, and square it. Same pattern every time. All right, same thing with the last one. Square root the first, 3u, square root the last, 4v. Multiply them, I get 12uv. When you double it, do I get 24u? All right, in this case, I don't. I get 24uv. That does not match this, so then I can't do this at all. None of this is going to show up in my final answer. I would leave it alone like this. If it had a v in the middle, then yeah, it would be 3u plus 4v squared, but it didn't have that v, so it's not going to be that. It's just going to be this. You would leave it alone. All right, last thing that we're going to do, right, 4 out of 4 factoring methods for this lesson is factoring a perfect cubes, right? So if I have a sum or indifference, it can be a plus or a minus, does not matter. It's going to be a bi times a tri, so a binomial times a trinomial. So I'm going to have a little parentheses and then a bigger parentheses. All right. It's going to be the cube root of the first plus the cube root of a second, right? If it's a plus, I'm going to keep the plus, so it's going to be u plus v. And then in my trinomial, it's going to be the square of the first, and then the last one's going to be the square of the last, right, plus, and then the product of the two in the middle, u times v. And then you see that I already filled in the pluses and the minuses. The signs for this are going to be the same sign, right? So that first one is going to be the same. That middle one is going to be the opposite. And this last one is going to be always plus. All right. Let's try the same thing with the next one. A u to the third minus v to the third. These are both perfect cubes, so I'm going to cube root the first, cube root the second. Keep the sign in the middle, so it's going to be a u minus v. And then it's going to be the square of the first, square of the last, and the product of the two in the middle. Once again, it's going to be the same sign, the opposite sign. So if it was a minus, it's going to be a plus, and the last one is always plus. All right, same, opposite, always plus. All right, same, opposite, always plus. I like to remember that using SOAP. Same, opposite, always plus. All right, so typically what I like to do, and you're going to see, I'm going to do x to the third minus 125. I'm going to factor it. You're going to see that I like to fill in the pluses and the minuses right away using SOAP. Same, opposite, always plus. Right, so this is a difference of perfect cubes, right? X to the third minus 125. Those are both perfect cubes. I like to write my parentheses, and I like to write same. So that's my same, my opposite, and then my always plus. So same, opposite, always plus. And then what goes in the parentheses is the cube root of the first minus the cube root of the second. Cube root of 125 is 5. And then in my trinomial, it's going to be the square of the first, square of the last, and the product of the two in the middle. 5 times x is 5x. And then this is fully factored. All right, let's try that with a couple examples. All right, x to the third minus 27. These are both perfect cubes, so I'm going to write my parentheses with my same, opposite, always plus. So I'm going to cube root the first, cube root the last. So I'm going to get x minus 3 in my first set of parentheses, and then in my trinomial, it's going to be the square of the first, square of the last, 3 squared is 9, and then the product of the 2 in the middle, 3 times x is 3x. Simple as that, guys. So this is something that you do kind of have to memorize a little bit. I tried to steer you guys from trying to just flat out memorize things, and I'd rather you guys try to learn them and put things in practice. But this is something that's best done, right, by memorizing it. Maybe if the pattern sticks in your head, then you can apply it anytime you see it, right? That's the goal here. All right, so let's try the same thing with the next one. Y to the third plus y to the eighth. These are both perfect cubes. So I'm going to fill in my signs, right? If there's a plus, it's going to be the same, opposite, always plus. And then I'm going to cube root the first, cube root the second. So it's going to be y plus 2. And then in my trinomial, it's going to be square of the first, square of the last, and the product of the 2 in the middle. All right, so I get that as my answer. Try the same thing with the next one, right? 64x to the third and 1 are both perfect cubes. So I'm going to write my parentheses doing same, opposite, always plus again. So minus, plus, and plus. And then I'm going to cube root the first, cube root the last. So it's going to be a 4x and a 1. And then in my trinomial, it's going to be the square of the first. So 16x squared, square of the last, so 1, and the product of the 2 in the middle. All right, and that's my final answer. Now, when you look at number 4, these are not perfect cubes, right? 3x to the third and 192. Maybe if you didn't know that right away about 192, you hopefully can tell that 3 is not a perfect cube. All right, so when this happens, think about what we did previously when things didn't work out right away, right? Typically, we try to factor out the common factor. And we're going to guess and say that the factor is 3, right? Why am I saying that? Is because this has a 3. I don't know off the top of my head if 192 has a factor of 3, but let's just test it out. All right, so I'm going to do long division, right? If I can't do that in your head, do long division. This is going to get me a 6, so 18. Bring down the 2, I get a 64. So it is divisible by 3, and then in parentheses, I'm getting an x to the third plus 64. And now this is a sum of cubes. So then, once again, I can do my parentheses and do same, opposite, always plus. I'm going to bring that 3 down just so that I don't forget about it. And then I'm going to cube root the first, cube root the second, and then in my trinomial, it's going to be the square of the first, square of the last, and the product of the 2 in the middle. And then that's your final answer. All right, doing a couple more. Let's do same exact thing here. Right, these are both perfect cubes. I don't have a common factor. So I can very simply just set up my parentheses, right, doing same, opposite, always plus. And the cube root of the first is going to get me 3x. Cube root of the second is 1. Then I can square the first, square the last, product of the 2 in the middle. Same thing every time. Hopefully it's sticking. All right, same thing with the next one. Cube root of the first, cube root of the last, right? These are both perfect cubes. So then it's going to be same, opposite, always plus. So it's going to be 4y and 5, square of the first, 16y squared, square of the last, 25, product of the 2 in the middle, 20y. And that's your final answer. Same exact thing if I have something a little bit bigger, right? So I can very simply, if I have a cube over it, it is a perfect cube. So I can set up my parentheses. I'll do bigger parentheses just to account for the bigger expression. So it's going to be same, opposite, always plus. So it's going to be the cube root of the first, x plus 2, cube root of the second, y, and then it's going to be square of the first. This entire thing is the first, square of the last, and then the product of the 2 in the middle, y times x plus 2. I would say that this is fine like this, but let's, just to clean it up a little bit, let's just simplify the inside a little bit more. right? The square of this is going to be a special product, right? So it's going to be square of the first, right? You can even write it twice and FOIL it if you wanted to. This is going to get you this. The second one, I can distribute that y, so this is going to get us a plus xy plus 2y, and then a plus y squared. And then that looks like as much as we can do to it. All right. So we get something like this as our final answer. Looks like there's no like terms to combine, so I can leave it like this. All right, so some of these examples get a little complex, but the patterns are exactly the same every time, right? So 4 main things that we covered this lesson, right? And like I mentioned briefly in one of the slides, when you're factoring, the first thing you always want to check is there a GCF, right? That should always, always, always be the first thing that you're checking, right? Otherwise, your answer is not going to be fully factored. And the second thing you should do is check for the special cases. Right? Are there special cases? And if there are no special cases, then you just leave it alone. For now, right? The next thing that we're going to do after this is going to be factoring any trinomial, and then we're going to factor 4 terms by grouping, right? But for now, and for the sake of your test, you should always follow these in this order, right? Check for the GCF first, and then check for your special cases, right? So the difference of squares, perfect square trinomial, or the sum or difference of cubes. All right, but that's it for this lesson. Hopefully not too bad. And then we'll review next.